Hello, my name's Steve Quern. I'm the creator of the Spacecraft Project Manned Spacecraft Design concept. Today, I am going to deviate from the Spacecraft Project to talk about Outerspace maneuvering, specifically in relation to science fiction space fighters. In order to do that, okay, I'm going to be making some models. Get over there. Okay. And then we need to rename that. Or get all of that. Wait a minute. We can name the material. Text. Although this yellow would be used for the sun also. So, but mostly it's used for text models. Project name. Okay, and then let's see here. So then we need to name this project Spacecraft Maneuvering. I am American, so there's no O in there anywhere. So, and then we need to scale that. Okay, scale 1 equals 1 foot 0 inches. We're going to do basically a single seat fighter. We're going to do this. I'm going to try to create that. This is a Blender project. I'm going to try to do something like that with PRISMA3D. Blender has a cone. If you look at the... Sorry about that. Oh, wow. I'm going way up here now. Okay, I'm going to have to do that. Okay. So, okay, where Blender 3D has a cone, PRISMA3D has a pyramid. You can make cones using cylinders too, so that's not a big issue there. This is okay, so we're basically replicating that. So, how are we going to do that? Oh, we need to rename it. Spacecraft Maneuvering. Okay. So, we're going to knock this down to $100. Okay, we do 100. Okay, then we move that up 100. Yeah, okay, yeah. I'm gonna, again, I don't have any paperwork. I'm just doing this on the fly. That's 110. Text. Font. Oh, no. Font. We'll do regular. We're not changing the material. We're renaming it. Okay. Scale on text. Oops. Okay, whatever. And then we're changing the scale 1 equals 1 foot 0 inch. Okay. Now we're going to scale that. 10. As much as I use this, I probably should make a model and save it and then download, then But I don't know how to go about doing that, and we're going to move it to negative 120. And I really don't I don't mind I'm not getting paid to do this, and so I'm not on a time schedule to do things, so it doesn't really matter to me that much. Now, models, cube, scale. Nope, not you. You. Scale. This is a human volume, so 8 feet high. 4 feet. 4 feet. This is standard American lumber volume. And rename it generic human volume. Another thing I could probably say, create a model on it and down and use it to import other projects. This is standard. Okay, so this is human volume. Move it to negative 130, see what that looks like. That's good. That's okay. Model that. Okay, and then we're going to not. This sucks. Can't just go straight to what I want to do. Okay, we're going to create a new material. Transparent. And we're naming this transparent. And then we're scaling that. So human volume is 8 by 4 by 4. So frame structure is 1 foot. So that's 10 by 6 by 6. This is based on USA residential lumber measurements. Okay, we're going to rename that generic spacecraft framework. And move that to minus 130. So you have an idea what we're playing with. Actually, I should put a new text on there. naming it. Okay, human volume model text. Okay. We're not scaling it. We're not doing anything else. Nope. Get back. Move it. Negative 125. Oops. Oh, forgot to do the font. We're going to do light, and we're going to move it again to 124. Yeah, okay. Scale that. 5, 5. I'll move that to 130. Volume, we move that to 140. This is going there. 135. And then we do the other one to 135. Wait. Oh, okay, that's right. There. Okay, so cockpit. We're going to so for the cockpit structure, we're going to have the guy in the chair, and we're going to have a guy standing behind the chair, and then we're going to have the console. So that's 8 feet for the guy and standing in the chair and behind the chair, and another 4 feet for the console. So that's 12 feet. Name cockpit interior. Let's see here. Scale that. X is this way. 12, that's what I want. We're going to have him be able to stand up inside the cockpit. And this is a one-man cockpit, so you only need volume for the spacesuit and some maneuverability. Okay, so that's cockpit interior. That's, oh, we want to move that because this is the construction site. So we're going to move it up to 100. And we're going to do another one. No, this is going to be the frame structure. Material transparent. And then we're going to do rename that cockpit framework. And then we're going to scale that. So it's 12, so 1 foot is 14. 8 with 1 foot thickness is 10. 4 with 1 foot thickness is 6. Get in that. And then we're going to move that to 100. I gotta rearrange how I'm doing my pedals. I'm slowing down all the time. Okay. So that's the basic cockpit structure. I can get more detailed right now, but we're going to just get the basic spacecraft design built. Actually, let's take a look at that spacecraft design. So yeah, that's okay, because there's things going on here that need to be discussed. Okay. No, I do not want to edit that. Okay, get out of it. Okay, yeah, there we go. Okay, images there. Okay, again, whatever. Okay, the cockpit is where the controls are, where the guy's sitting and stuff. This cone shape is the avionics, radar, and whatever happy stuff you need for traveling. This area, okay, this is the cockpit. You have where the controls are. Then this cone is the avionics section, radar, and whatever happy sensors you need to have for space flight and aerodynamic flight. This colored area, this pink, is the airlock. And this green area, that is the nexus point. That is the XYZ center of gravity center point. It's the if I can I can't rotate. This is not a project. From the nozzle end to the tail tip is the nexus, is the center point from the tail to the tip, from nozzle to nozzle. Okay, so the control panel 4 feet, chairs for 4 feet, and the standing behind the chair 4 feet. Okay, we're not changing that. And then we're going to have the airlock. And then we're going to have the nexus point. And the nexus point is going to be the size of the fuel tanks and stuff. Fuel tank and oxidizer tank engine. So, we're going to have to calculate all of that. So, the airlock now, I don't know what goes into the technology of the airlock design. You have to have air pressure systems. And stuff like that. You name that. Airlock interior. This is the actual spacing that is needed for the astronaut. Okay, so scale that. Basic human volume. let's see here. That. Airlock framework. And we're just going to do the 1 foot wall scaling. Let that deal with that later. Nope. 6. Okay, now we're going to move that up to 100. We're going to move that over to 8. Let's see how that works. Nope, wrong 8. That's like 10. Oops. That's correct. And so we do the airlock, interior, move that 100 minus 10. Okay. Now we're going to do the engine nozzle, the main engine nozzle. And we're going to say 8 feet. This is going to be, main engine nozzle. And down there. Okay, we're going to have to zoom out a little bit. Let's see here. We want to change that material. We're going to do a new one. Color code it. Let's see that. Okay, 000. Come on. Okay. Okay. Right about there. Simplify the coding. Okay. Rename that. Nozzle. I want that a little bit blacker. Material, color. Yeah, that's better. This is not the same. Don't get out of there. That's the one I want. That's okay. Oh, I gotta get out of that to do that. Okay, that's not the same color coding I have used on my other projects. Again, I could. This model could be saved and then reused. I don't know how to go about doing that, and this would be a lot easier. Okay, and this process would be, the spacecraft design would be done a lot faster. However, I'm using multiple engine sizes. So, this is not gonna, okay, scale that. My typical engine scales is 8 feet by 8 feet by 8 feet, which is based on the 75 F1 engine. And also based on my F1 SDQ engine concepts. Now what I sometimes do is I create a bigger engine, which uses a 10-foot nozzle and a 5-foot by 5-foot by 5-foot motor, cryogenic, multi-start, variable thrust concept, which may actually, if you designed the F1 engine, the F1 engine is a kerosene burning. If you convert it to a hydrogen burning engine and you want to have it pump out the same amount of volume, I think it would be if you're using that as for the F1 SDQ model, I think it'll be larger than the F1 engine, the Apollo 5 one engine, by a few inches, and so it may end up being a 5-foot by 5-foot by 5-foot motor, actually. So I don't, that's not, okay, I need a new model because I am going to scale that. No, come on, no. This is not hooking, it's not auto joining. Okay, scale that. Oh, come on, not again. Scale that. Okay, oh, that's the, okay. 8.1. Okay, and then we're going to go with 4. Okay, this. Okay. Cylinder. All of that. Delete that. Get all that mode. Get all that mode. That way you don't screw things up while you're maneuvering around. And then you get the cylinder. In version 2, sorry. In version 2, the values stick. So you can modify, you can keep, this would be a measure cylinder, and I can change the values, you can change the scale on scale values. You can use it for it. Right now I can use this for to make the engine to do the engine nozzle design. But then when I'm done with that, in version 2, I can rescale this to make a smaller engine design, nozzle design. Okay, now I'm trying to find I should, okay. Okay, engine nozzle, but because the values don't stick, I'm going to have to delete the this model. And okay. Scale that. Okay, undo that. That's not working. Okay, I gotta go.